Day 548 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2257. Count unguarded cells in the grid. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given two integers m and n representing a zero index n by n grid. You are also given a 2D integer array guards and walls where guards of I is equal to row I column I and walls of j is equal to row j column j represent the positions of the ith guard and the jth wall respectively. A guard can see every cell in the four cardinal directions north, east, south, or west starting from their position unless obstructed by a wall or another guard. A cell is guarded if there is at least one guard that can see it. Return the number of unoccupied cells that are not guarded. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input m equals 4, n equals 6, guard equals a 2D array of integers, first array 0, 0, then 1, 1, then 2, 3. Walls is also a 2D array of integers, first one 0, 1, then 2, 2, then 1, 4. The output is 7. Explanation says the guarded and unguarded cells are shown in red and green respectively in the diagram above. There are a total of 7 unguarded cells, so we return 7. All right, y'all, so let's break this down one step further, right? So we have our input guards and our input walls, so in our n by n. So first, m, that just represents the height, then n will be the length right here. The length is 6 right here. Then each one of these arrays inside of the 2D array and guards represents where the guard is going to be at in this n by n grid. So we have a guard right here on 0, 0. This is 0, 0. We have a guard right here at 1, 1. This is 1, 1. Then we have a guard right here at 2, 3. And this is 2, 3, right? Because as you can see, we come down 1, 2, then go over 1, 2, 3. That's where we're here. Then for 1, 1, we come down 1, go over 1, and then 0, 0 is right here. Similarly, for walls, it's the same thing, represents the points of the wall. So we have a wall at 0, 1, we have a wall at 2, 2, and we have a wall at 1, 4 right here. So these just tells us where the walls are. Now, we want to see which part of this grid is unguarded, right? So these guards can see in every direction. This guard can see left or right, down, and up, unless it's obstructed by something. So in this case, this guard right here can't see past this wall because there's a wall right here. Similarly, this guard right here can't look this way, he can't look this way or look this way, but he can look this way. This guard can look this way, he can look this way, and he can look this way, but it's a wall right here blocking this path right here. And also when this guard looks this way, he can only see up until the wall, right? So if there's a wall right there, the guards do not have see-through vision, so they cannot see through these walls, which is why this cell is unoccupied because there's no guards that can see it. This guard can't see it. This guard can't see it because of the wall, and there's no other guards in this column. So this cell right here is unguarded. Also, this cell is unguarded because there's no guards right here that can see this cell right here. So this cell is safe. Now, these cells are safe as well because the guards can't see. There's no guard that can see these positions as well, right here, and also right here and right here. So as you can see, there are 7 green cells total, and that's why our output is 7. Now, just in case that didn't make sense, let's take a look at example 2. So now, example 2, our input equals m equals 3, n equals 3. Guards is a 2D array of integers. Only guard is 1, 1, is at 1, 1. And then walls, we have a wall at 0, 1, a wall at 1, 0, a wall at 2, 1, and a wall at 1, 2. This is what it would look like if these were written or shown as a diagram. And as you can see, this guard cannot see in any direction because he's surrounded by walls, But since there's walls right there, that also means it's not an open cell. So the only open cells are these 4 open cells right here, highlighted in green, that the guard cannot see. And since there's 4 of them, then our output is 4. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Y'all, solution is not that difficult at all. So let's get into it. Now, the first thing we are going to do is we're just going to create a 2D grid that we need to initialize. We're going to initialize it just with zeros to start, but we're going to say declare variable called G. We'll set that equal to an array. Open up the parentheses. Say repeating. Repeating colon is going to be repeating zeros. Then we're going to say comma count colon n. Or actually, sorry y'all, it's a 2D array, so it's actually going to be repeating another array. Then we are going to open up the brackets and we're going to say repeating, and then this array is going to be repeating zeros of count colon n, and then the first array is we're going to say comma count colon m, just like that. Now we need to mark the guard positions as 2, so which will mean they're occupied. So we're going to let the 0, if they stay 0, that means it's still an unguarded cell. When we come across a guarded cell, we're going to mark it as 1, and when we come across an occupied cell with either a guard or a wall, when we come across a cell that's visible by a guard, we're going to mark that as 1. And if we come across a cell that is occupied either by a guard or a wall, we're going to mark that as 2. So to do that, first we're going to say, sorry y'all, for E in guards, we're going to open up the brackets and we are going to say G square bracket E square bracket 0. Come outside of that, we're going to say square bracket E again, and then we're going to say square bracket 1 still inside of that. Boom. And sorry, yeah, this should be a 2D array as well. So this, oh yeah, let me see. Yeah, that shouldn't be 3. It should be 2D. Sorry, y'all. So this should be like this, and this should be like this. Boom. Then we could just say equals 2. Boom. So like I said, we're going to mark that as 2 when we come across an occupied cell either by a guard or a wall. Now we need to mark wall positions again. Now, or that's for guards. Now we need to mark wall positions as 2. So for that, we're going to say for E and walls this time. We're going to do the same thing. We're going to open up the brackets. We're going to say G square bracket E square bracket 0. Come outside those square brackets. We're going to say square bracket E square bracket 1. And we're going to set that equal to 2 as well. Boom. Now we need to get the directions array for up, right, down, or left movement. So we'll come underneath this for loop. And we'll say let dirs for directions equal, open up the square brackets, -1, comma, 0, comma, 1, comma, 0, comma, -1. Boom. Then we're going to come underneath this. And we're going to say, so for each guard, we're going to spread their line of sight in all 4 directions. So we're going to say for E and guards. Then we're going to open up the brackets and we're going to say for K and 0 ... less than 4 for the 4 directions. Then we're going to open up the brackets and we're going to start from the guard's position by saying declaring a variable called X. We're going to set that equal to E square bracket 0. Come outside the square bracket, we're going to say 1, comma, then we're going to say set Y equal to E square bracket 1. Boom. Then we're going to come underneath that and create our direction vector by saying let dx equal dirs square bracket k, come outside the square bracket, comma, dy, dy, we're going to set that equal to dirs square bracket k plus 1. Boom. Now we need to continue moving in this direction until we're either out of bounds or we encounter a wall. So we're going to come right here underneath this, and we are going to say while x, this is a long line, y'all, so pay attention. Yx plus dx is greater than or equal to 0, and two and signs, x plus dx is less than m, and two more and signs, y plus dy is greater than or equal to 0, and two more and signs, dy is less than n, and two more and signs, g square bracket x plus dx, come outside of that, and we say square bracket y plus dy is less than 2. Boom. Then we can open up the brackets, and we're going to say x plus equals dx. Come underneath that, we are going to say y plus equals dy. Come underneath that, we're going to say g square bracket x square bracket y. We're going to set that equal to 1. And that's going to mark this cell as guarded or visible by the guard. And then we're still not done yet, because we still need to count and return the total number of unguarded cells that still have a value of 0. So to do that, we are going to come right here, and we're going to say return g dot reduce, open up the parentheses, passing 0, come out, sorry y'all, passing in 0, not O. Boom, come outside the parentheses, open up the brackets, we're going to say $0 plus $1 dot filter, open up some more brackets, we're going to say $0 is equal to 0, come outside those brackets, we're going to say dot count, y'all, and that should be all that she wrote. Let's give it a run, make sure it runs correctly before we submit it. Okay, we have an error. Let's see where we went wrong. I assume it's somewhere in this line. This line just feels janky. So give me a moment while I read through this to make sure everything is correct here. Let me see, and it seems to be, oh, okay, here it is. So this should be y plus dy is less than n. So now let's run that and see if that fixes this. Hopefully it does, and it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 64 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. Boom. This is the bottom. And yeah, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.